So this is a quick demonstration of the risa program, how to open it, how to change some of the basic overall rules of the model. So obviously you can open up the program by clicking the icon. You can also go to the file folder, like where you have the model located. This is lecture 12, where we first introduced the model. So if I click on that, it opens it up. Pretty similar to any program you're using. So we'll call this model test 1, question 3. IIT, and I'll put my name in here, SJK. Um, we're not really going to change anything else in this dialog box. One thing you could do, you can go into codes. Right now the code is listed, the ACI 31811. That's going to be okay for what we're doing, but let's go back and change this to the 05. That's our textbook is written around, based around the 05, so let's be consistent and change that. So we'll apply this. Make sure we've applied this. Close this out. Don't worry about this error log. This is a model I think was originally created in a newer version, and there's an issue with the wood connectors. Well, we're not using wood connectors here, so we don't have to worry about this. X that out. So you can see the model that we set up, effectively two different beams. One, a continuous span beam over three lengths, and here we have the simple span beam. So let's go through some of the things, or some of the ways that you could change this model. The pull-down menu we're going to be using is the spreadsheets. So we won't be using the modify, use the spreadsheet. So click on that and go through a couple of these. First thing is materials. Now a lot of these are built into the program. We're going to get out of the steel materials. We'll come over here to the concrete, click on that. So a lot of these are already input into the program for us. I've added here the concrete 5000 normal weight. I had to calculate the E value, the modulus elasticity. I also had to calculate the shear modulus. We really don't have to change that. That's not going to affect what we're doing in this class. If you wanted to add additional concrete strengths, you could. You just have to calculate the new E value each time, which you know how to do. You have to input the density of the concrete. So if normal weight 145, I have to input the F prime C, or the concrete strength. This lambda factor, it's going to be 1 for using normal weight, 0.75 if we're using the lightweight. And then our steel strength is always going to be 60 KSI. So really the main ones here are the E value and this F prime C. So let's click out of that. It's all set up for us. Next one, go to the section sets. So we'll come through here. We've got the steel sections, wood sections. Let's go into concrete. So I've added a few new concrete sections. You can add really as many as you want here. Let's just go on the bottom here. We'll hit enter. Takes us down to a new box. So let's add a new beam. Let's say we've got a 12 by 30. So we'll go over to here, click on this. This is where you enter the geometry of your new beam. Oops. Click on that. It is a beam. We could also change this to a column or to a brace, but we're going to keep all these as beams. It's a rectangular section. Here's where you input the material. So you could change it to the different material strengths, but typically in a model, you're going to keep all of your beams the same concrete strength. Design rule, we don't have to worry about that. The cross-sectional area, the program is going to calculate this for you. It's also going to calculate the moment of inertia about each axis of the cross section, and I'll talk about this in a second. These are called the local axes, these small y and small z. And it's also going to calculate the torsional stiffness here. We're really not going to use that in that class either, but the program calculates those values for you. So again, you can add as many different beams as you want. If you're doing columns, you can add as many different columns as you want. So we'll click out of that. Actually, one thing I'll show you here. If you do have a question about any of these pull-down menus or dialog boxes, you can always hit the right mouse button and go down here to the help menu. And it's going to step you through that particular box that you have open. Okay, so you can do that pretty much any place within the program, any dialog box that you have open. Also can go up to the help menu here. We were talking about the local axes. Let's do a search on there. So local axis. Okay, so I'll click on that. And I'm going to page down here. So in any model, you have the overall axes, the global X, the global Y, and global Z. Well, for every individual structural member, you have a local axis as well. You're not going to have to worry too much about this. I just wanted to point this out to you because when we do a model, we always have to make sure that we have the member rotated correctly. So sometimes we'll draw the model, we'll take a look at it, and we'll have to go back in here and rotate it because we have the axes, rotated 90 degrees. We always have an I end of the member. We always have a J end of the member, and that's how you draw the member. So if I have a node here and a node here, and I draw it from this node to this node, the program automatically assigns this the I end and this the J end. The axis parallel with these 2 points is called the local X, and then you've got these perpendicular axes, the local Z and the local Y. So once you get into moments and shears and forces within each individual member, typically those are given to you in the local axis versus the overall global axis. So let's X out of this. Next thing I'll go down to here is the joint coordinates. So this is where you can change the length of these particular beams. So this is now set up 30 feet from node 1 to node 2, and then from node 3 to node 4, that's also 30 feet, 4 to 5, 30 feet, 5 to 6, 30 feet. So you can really modify these however you see fit, depending on the beam you're analyzing or the beam you're designing. Okay, so that's what we're going to be using to change our geometry. So I'll click out of that. Next one, the boundary conditions. Now, you're not going to have to change any of these, but I just wanted to point this out. These are all pin connections, so it's a very, very simple model. Typically at the end of a beam, most likely that's going to be connected to another beam or a wall or a concrete column. As you know, when you connect those two concrete members together, you will get moment transfer across those. Well, let's keep it simple here. We're just connecting to a simple pin support, so there will not be any moment transfer to any of these pins. Okay, so we're keeping it simple here. One thing we have to do in a three-dimensional model is you have to prevent this beam from being able to rotate about its own axis. If you're working in 2 dimensions in a 2D program, you wouldn't have to do that. The program would know that it's fixed in that three-dimensional direction. Well, in this case, because we have the 3D program, we have to fix it. So you're going to see these different looking joints here at the end. Basically, they're still pinned, so we just have reactions in the X, Y, and the Z, but we're going to fix the X rotation. So X axis here, X axis. So this beam cannot rotate about this axis. This beam cannot rotate about the axis. So just wanted to point that out. If you wanted to change these to fixed and experiment, if you changed a connection here to a fixed connection, how would it change the moments? You could experiment a little bit with that. Let's click out of that. And then we have the members themselves. So as I mentioned, you do have an I joint and a J joint, and that's just how I drew it. So if I start with a node here, and I draw the member from that node to that node, this automatically gets assigned the I node, and this automatically gets assigned to the J node. You can see that I have the section assigned. And so again, I can change this. So I had a 1624. If you remember all the beams that we had in this model, I could change it to one of the other beams. Let's change it to the new beam that I added, the 12 by 30. I'll click on that. So now that beam 1 is the 12 by 30. Um, all of these are signed in this beam, so I can't actually go in here and change those. Not going to let me do that because I assigned that within the actual section set. Okay, so this particular beam, this 12 by 30, all the 12 by 30s have a concrete strength of 5,000. Now I mentioned the local X and Y and Z axes. Now if we go down here, let's click out of this, and I'm going to render this model. So one of the things you can do, you hit the F2 button, and that's going to bring up a little dialog box that helps us change how this is displayed. So I mentioned this is the M1, or the member number 1. All right, so if I go here to members, click on that. Well, there's no label. Let's add a label to it. So now all these are labeled. So now I know which one's M1, M2, M3, and M4, and so on. Click the F2 again. Let's say I want to see the shape instead of the label. So I say shape. So now it's telling me all the different beams that I have. Let's see, I thought I'd change that to, let's see. I'd change this. Why is that not changing? Hmm. You know what I did? I did not label it correctly. 12 by 30. There we go. Now it's labeled correctly. Okay, so that's where you can bring up the sizes. Another thing you can do, go to F2 again. We can bring up a rendered view. So it's 80% of the length. And now I can see how the member is oriented, how it's rotated. Now, sometimes you'll draw a model and you'll get this thing oriented in the wrong direction. So we're going to be loading this vertically in the y-axis. Let's see if I can go back to spreadsheets, members, M1 member. If I go to rotate and say 90 degrees. So now I've rotated it. So I've rotated about the x-axis, effectively changed the local axis because I had it incorrect. So oftentimes, once you get the model done, it's a good idea to render it, take a look at the different shapes that you're using, make sure you have those oriented in the correct location. So we were good, so I don't have to go back and do this. Let's change that back to 0, bring that back to where it was. All right, so click out of this. So those are really the things that you're going to be using to change the model, change the geometry. Next thing I'll do is I'll go through the loads, load cases, and so forth. So that'll be the next video that we go through.